Hi guys, in this video I'm going to talk to you about a C++ memory map and the syntax to declare a pointer and some other basic operations on pointers. So what I first want to tell you is that after compiling your program, C++ organizes creates four logically distinct chunks of memory for four different purposes, and one of these chunks is the chunk that stores the program code. That is, as we run, this actually has the code. It holds the compiled code, every instruction, every function, and as the program runs, the thing refers to this to execute every little statement. And then we have global variables. These are variables which are present throughout the whole runtime of the program, so we have that in one separate section. And then we have stack. These are where all our statically allocated variables are stored, and I guess I didn't tell you this last time. All the regular variables that we declare in chars using our regular syntax, they're all statically allocated variables, because the scope of those are basically controlled by the compiler. So all our regular variables are statically allocated. So all of these regular variables go into one section of memory, like all your local variables for functions and all that. So basically regular variables, they go into the stack, which is one section of memory. And before we when we compile, the compiler can actually calculate how much stack you need depending on how by counting how many regular elements we've actually declared. So the compiler knows how much stack we need and accordingly assigns that much stack. And then we have a fourth element, a fourth part of our a fourth chunk of memory, which is called the heap, and this is where all our dynamically allocated variables are stored. And now, since dynamically allocated variables are basically initialized, declared during runtime, the compiler doesn't exactly know how much space we need, so it just gives us a blob of memory. It may or may not be enough. In fact, there can be scenarios in which the heap is not enough and we run out of space during the processing of the program. So the syntax to declare a pointer, so we will go to that now. Syntax to declare a pointer is type star name, where type is the type of the element to which the pointer points, and name is the name that you want to give to the pointer variable itself. So let's say we want to declare a pointer that points to a character, and we want to call it C1. So we declare it as follows: CHAR star. We want to call it C1. So C1. We want to call it C1. That corresponds to the name part. Type is char, and star is just something which is there, which tells the compiler this is actually a pointer that I'm declaring. If you want to declare a pointer to an integer and you want to call the pointer itself I1, then we do it as follows: int star I1 semicolon. So I think you get the basic idea. And I want to tell you something very important about pointers. Sorry about that. As you probably know, like most of the fundamental data units that we have in C++, they occupy multiple bytes, like floats and ints and all that. The only one which doesn't, I guess, is char. So most of them occupy multiple bytes. So what the pointer does, like I told you, it can only store the memory location of one byte. So what it does is basically it points to the first byte in case of multi-byte elements. So, but how does the program know? Like, the pointer points to something, and when you want to process what the pointer points to, the program has to know how many elements, how many bytes after the first byte it has to take if it wants to process the whole element to which the pointer is pointing. For that, that's why the compiler needs to know that. The program. So that's why it's important to declare the pointer type, although all pointers are technically the same, they just store one memory location. That's why it's important to declare the pointer type. So if we declare the pointer type and we have a float pointer, that is a pointer which points to a float, the pointer itself will only have the first memory location. So since the program knows it's a float, it'll take, when we want to process what the pointer is pointing to, we take the first location, the location that the pointer is pointing to, plus the next three, and process it. But if we have an int which is 2 bytes, it'll take the address to which the pointer is pointing and the next byte and process it together. And we want to know, I mean, the program needs to know which how many along with the bytes along with the first byte it needs to process. That's why we need to declare the type of the pointer. And now I want to discuss two basic operations that are used with pointers: the ampersand or and. I mean, it's the ampersand operation, and what it does, it's a unary operation that operates on a regular variable. It returns the memory location of that variable. So let's say first we declare an int star a, basically a pointer called a which points to an integer, and then we declare an integer b which has a value of 5, and we say a is equal to star b. This means that, I mean, not star b, ampersand b. This means that the ampersand operator is operating on b, and it returns the memory address, the memory location of b, and so star b basically returns the memory location of b, and that is stored in a. So that makes sense, because a is a pointer, it's supposed to store a memory location, and if we say a is equal to star b, it will store the memory location of b. Now we have another operator, basic operator, that is associated with pointers, that is the star or asterisk operator. This is also a unary operator, and it operates on a pointer. This actually operated on a regular variable. This operates on a pointer. What it does is basically returns the value of the memory location at to which the pointer is pointing. So if the pointer is pointing to an integer, what star of that pointer will do, you'll get the value of the actual integer itself. Let me explain what that means with an example. So we declare an int b with a value of 5, then we declare a pointer a, and then we say a is equal to ampersand b. That means a gets the memory location of b, and then we say cout star a. So a itself is a memory location, so when we say star a, we mean go to that memory location, find out what value it's holding, and cout that. So since a is pointing to b, the value that the value that this will produce is 5. So what will get printed on screen is 5. So let me explain once again. It goes to that look. If we have star a, where a is a pointer, it goes to the address to which the pointer is pointing, retrieves the value that's there, and operates on it, basically, or prints it, or does whatever the user wants with it. Now I want to make something very, very clear. The star operator is completely different from multiplication and different from the stars that we use in pointer declarations. That is, when we say int star a, this is completely different from the operator itself. In declarations, we simply put the star to say that we are declaring a pointer, while in proper statements and equation kind of things, it's an operator, just like plus, minus, modulus, etc., and it does what I just told you it'll do. Now let's review what we've done with a basic example. So we say int number is equal to 5, and then we say int star a is equal to ampersand number. Now int star is the pointer type, so a points to an integer, and we say a is equal to star number. So this is basically combining the declaration int star a with the statement a is equal to ampersand number. So we say let's declare a pointer a, and as soon as we declare it, we'll store the memory address of number into a. So because that's what the ampersand operator does. So now in a we have the memory location of number, and when we refer to A by itself, it actually prints out the memory location. But like I told you, the star operator, what it does is go to that memory location, retrieves the memory, and brings it back. So when we say cout star A, what it'll do is go to the memory address of number and retrieve what's there, which is obviously 5. So cout 5. So I think that made the operations of pointers and all that relatively clear. Now I'll see you next time. Thank you. Bye bye.